I was discussing with MN test. Good morning. Okay, so I was discussing with MN test. That means it will help you to test the uniform convergence of a sequence of functions. It says that this Fn converges uniformly on a given interval if and only if limit Mn is 0. What is Mn? Mn is the supremum of this number Fnx minus fx, and x is from I, and this is a if and only if condition. That means if limit Mn is 0, then uniform convergence, and if limit is not 0, then not uniformly convergent on that particular interval. So I'll start with a basic example. I'll give two examples from MN test, and that will complete MN test, and you may try other examples using MN test. So the first question is this: define fnx like this. Define fnx like this. Fnx is x by 1 plus nx square, x from 0 1, and definitely n can be any natural number. So I have f1x, f2x, f3x and so on. Show that this converges uniformly on this interval 0 1. So on 0 1, this sequence of function will converge uniformly. Here is the proof why. So my aim will be to find Mn. Mn is the supremum of these numbers. Okay, so first my aim is to find Mn, the maximum value in the interval, where x runs in the interval, and maximum value of this one. So to find this, I should first find fx. And what was fx? Fx is the pointwise convergence. So fx is nothing but limit n tends to infinity fnx. This is the definition of fx. This is x by 1 plus nx square divided by n. This is x by n divided by 1 by n plus x square. Now the good thing is, whatever x you choose, x can be 0 1. Whatever x can be you choose 0 1, 0 0.5, 0 0.9, this is going to 0 and this is going to 0, right? This is going to 0 and this is going to 0. So what I'm getting 0 by x square, which will be 0 for all x not equals to 0. Right? You see, what is fx? Fx is limit n tends to infinity fnx. Whatever x you choose other than 0, you see, this is going to 0 and this is going to 0. I am remaining with 0 by x square. 0 by x square will be 0 for every x, but x should not be 0. So I have calculated the limit function for all x except 0. When x equals to 0, you see, what is this one? What is this sequence fn0? It is nothing but this is this sequence. When x is 0, f1x is 0, f2x is 0, f3x is 0. So 0, 0, 0 and so on, which converges to 0. Therefore, what is the limit function? Fx was nothing but limit n tends to infinity fnx. This is nothing but 0 for whatever x you choose from 0 1. So the limit function is identically 0 in the given interval. Did you get my point? Firstly, you always have to find the pointwise convergent limit. right? Did you get my point or no? This is the pointwise convergence. So fnx converges pointwise to this function fx. Fx is 0. Now you see what is my next task. My next task is to find mn. Mn is what? Supremum of this thing. So I have to find the maximum value of fnx minus fx. And x maximum value of this where x runs from 0 1. From 0 to 1, right? So this is what? Fn is x by 1 plus nx square minus 0. So this is nothing but x by 1 plus nx square. I have to find the maximum value of this one. That means I have to find the maximum value of this one, right? So suppose I say this as y as x by 1 plus nx square. So I have to find the maximum value of this quantity. So one technique of finding maximum value is, maxima minima. You all have been doing in class 12, no? Maxima minima, dy dx equals to 0 and so on, right? I'll use that technique. There's one more technique to find the maximum or minimum. It is EMGM method that you have done in inequalities. Anyways, I'll use the maxima minima method. In MAPA, they have used inequality technique. That means that one, EM is greater or equals to GM. But I'll use maxima minima technique. Now you see, I have to find the maximum value of this quantity, right? So start differentiating, you have to do the differentiation and equate differentiation to 0 and so on. So let's do that. So dy dx, what is dy dx? I have to use the quotient rule. This whole square 1 plus nx square, derivative of x is 1 minus keeping x outside, derivative of this is 2nx. You simplify this a bit, 1 plus nx square minus 2nx square. So this will become minus nx square by 1 plus nx square whole square. Did you get my point? This is how you find the differentiation. You know the rule. What do you do for maxima minima? You equate the first order derivative to 0. Are you getting my point?
Yes, sir.
Yeah. So let's equate dy dx equals to 0. So for maxima and minima, what we do, we equate the first order derivative to 0. Dy dx equals to 0. What was the derivative? What was the dy dx? Nx square by I'll not give you time to copy. You copy later on because time is very less. 0. So this cannot be 0 because this is always positive. You see, n is positive, x square is positive, 1 is positive. So 0 into this number, this is always positive number. So that vanishes. The only possible thing is this can be 0. That means nx square equals to 1. That means I have to find for x, no? X square equals to 1 by n. So x equals to plus minus 1 by root n. Okay, x will be plus minus 1 by root n. It can be minus also, but I will not take the minus 1 because look at the interval. The interval is 0 1. My x should be in this interval. If I take x as minus 1 by root n, this will not lie in the interval. Don't forget that I have to find the maximum value where x can be from, x should be from the interval. So I am not choosing x as minus 1 by root n because that will not belong to the closed interval 0 1. So the maximum value, I don't know. I just know that either the maximum or minimum will be achieved at this value. At this value. When x is 1 by root n, then maximum or minimum will be achieved at this value. Did you get my point up to here?
Yes, sir.
Now you find out the second order derivative to verify whether at this point maximum value is achieved or minimum value is achieved. You find out the second order derivative. So you know how to find the second order derivative. You differentiate this quantity, but again due to the lack of time I will just leave that part up to you. I'll just write down the standard result. What will come after differentiating? You just verify that. It is going to come something like this. Minus 2nx 1 plus nx square minus 4nx 1 minus nx square over 1 plus nx square whole cube. 1 plus nx square whole cube. So you try to verify whether this d2 by dx2 is coming or not. It will definitely come this. So to verify this is the point of maxima or minima, I have to check the sign of the second order derivative. So I will check the second order derivative at x equals to 1 by root n. You in the second order derivative you put x equals to 1 by root n. Whenever there is x, you put x equals to 1 by root n. What you will see that you will get minus of this quantity. Are you getting my point? You just check. You put x as 1 by root n everywhere and you will find this, and this is less than 0. So maxima or minima? This point is the point of maxima or minima? Sorry?
It's a point of maximum.
Very good. This is the point of maximum. So therefore y is maximum when x equals to 1 over root n. Right? So my aim was to find the maximum value of this. So this means this. So I calculated the maximum value. Sorry, I just know that at what point the maximum is achieved. But I have to find the maximum value. So how will you find the maximum value of y? You put x equals to 1 by root n here. So and maximum value of y will be what? It was x by, what was y? X by 1 plus nx square. 1 plus nx square. X square will be 1 by n. It gets cancelled. 1 plus 1, 2. It will become 1 by 2 root n. So the maximum value of this quantity is 1 by 2 root n. So the maximum value of this quantity is what? It is 1 by 2 root n, and we call that maximum value as mn. So I'll write that. So let mn equals to supremum fnx minus fx x from the domain. Here the domain is 0, 1. So what is the maximum value of this quantity? We just calculated it is 1 by 2 root n. Did you get my point? How do we find mn? Yeah. So now since limit n tends to infinity, mn, what is this limit? This limit is clearly 0, 1 by 2 root n. This goes to 0. So therefore fn converges uniformly to fx to f on 0, 1. Hence we are done. Hence we are done. Right? So this is the use of MN test. But remember one thing, you see, the maximum value is achieved at 1 by root n, and this should belong to the interval. This 1 by root n is a number between 0 and 1, so that x will belong here. If I give you any other number, then MN test will not be used. Like if I take another interval 5 to 6, then you see this number x will not be there in that interval 5 to 6. So you cannot use MN test there. Got the use or no? Yes. So this same sum is done in MAPA, but to find the maximum value, you see everything is same, but to find the maximum value they have used the inequality concept, AM greater than equals to GM. You can also do that. Okay, I'll show you one more example from MN test, and that will complete MN test. You can do other examples from your book. So another example that I'll show is this. Show that the sequence of functions fn, where what is fn? Where fn x is nx by 1 plus n square x square, nx by 1 plus n square x square is not uniformly convergent on any interval containing 0. On any interval containing 0. That means this sequence of function, where the sequence of function is defined like this, this will not be uniformly convergent on any interval containing 0. You take the interval closed interval 0, 1, closed interval 0 to 5. In any of these interval, this sequence of function will not converge uniformly. So again we will make use of the MN test. Okay. So your first task is again to find the pointwise limit. So if you remember, for this function I have already calculated the pointwise limit. I'll show you, just a minute. Yeah. So again I am not going to do this. For you see, for this function nx by 1 plus n square x square, for 0 it is 0, for any x not equals to 0 it is 0. So the what is the pointwise limit? The pointwise limit is this, identically 0. It's already done. I am not going to repeat everything. For 0 it is always 0, which converges to 0. For x not equals to 0, again the same technique, this is 0, right? So done. So again I write the same thing here, that solution here fx, which is nothing but limit n tends to infinity fn x, is 0 for all x over real numbers. Whatever x you choose from the set of real numbers, the pointwise limit is going to be 0. So this converges pointwise on R to the identically 0 function, but it will not converge uniformly on any interval containing 0. Let's see how. So now what I will do, I will find fn x minus fx. What is this? This is nx by 1 plus n square x square. I have to find the maximum value of this quantity. Right? I have to find the maximum value of this quantity, because this is 0. So I'll do this. I'll do in the same way. Y equals to nx by 1 plus n square x square. Did you get my point? I am doing in the exact same manner. by which I did the previous sum. I'm following the same technique. Now our task is to find the maximum value of this. Okay, our task is to find the maximum value of this. So what I'll do, I'll find dy dx keeping this outside. Derivative of nx is n minus keeping nx outside. Derivative of this is 2n square x. This will come to n plus n cube x square minus 2n cube x square. So minus n cube x square by 1 plus n square x square whole square. Just take n common. So 1 minus n square x square by 1 plus n square x square whole square. Clear up to here? This is such derivative you all have been doing in class 11. Now for maximum minima dy dx equals to 0. So let me write the same thing. For maxima and minima, dy dx must be equal to 0. That means n times 1 minus n square x square by 1 plus n square x square whole square must be equal to 0. This cannot be 0, this cannot be 0. So only possibility is 1 minus n square x square will be 0. That means x equals to 1 by n. Right? Did you get my point? Yeah, now you see my point is this number, what I said, I'll find the maximum for all those x where x belongs to the interval. So my claim is this number will belong to any interval containing 0. Why? You see, x equals to 1 by n tends to 0 as n tends to infinity. That means this number 1 by n will be there in my interval containing 0. Whenever I have an interval containing 0, then in that interval this x is definitely going to lie, right? Because this is very close to 0 due to this fact. Again and again I am repeating the same thing. Whatever x is coming, that should belong to the interval. Here x was 1 by root n and the maximum value is achieved at this point, and this point is in the interval. So I can say the maximum value is this. If this x would not belong to the interval, then I cannot say that the maximum value is this. So this is the reason they have said any interval containing 0. So if I have any interval containing 0, this x will definitely lie in that interval. So now your task is to find the second order derivative, and that is your task, okay? And put x equals to 1 by n there. You are going to get something like this. You will exactly okay, you'll get something less than 0 for sure. You check this. You just check this. So what can I say? Therefore, y is maximum when x equals to 1 by n. Did you get my point? Am I going too fast? If you have confusion, feel free to ask. Please ask. Clear, right? Up to here? Or do you have a confusion? Very good. So let's find the maximum value of a y. I know y is maximum when x equals to 1 by n. So therefore, maximum value of y is what? You see, what is the maximum value of y? This is the thing, no? Y is this, nx by 1 plus n square x square. Nx by, so nx by 1 plus n square x square. What I am getting, this is getting cancelled, this is getting cancelled. I am getting the maximum value of y as half, independent of n. So let mn be the supremum. So let me take that interval. Let ab be the interval, be any interval containing 0. I am taking any interval AB containing 0. I'll prove that the function is not uniformly continuous there. So Mn be the supremum x belongs to AB modulus of fnx minus fx. So because 0 is here in this interval, so this number 1 by n is in that interval. So the maximum value of this thing is going to be half. So what is the maximum value? It is going to be half. So mn is coming as half for all n in natural number. So you tell me, what is limit mn? What is limit mn? What is limit mn? Limit n tends to infinity. Mn is half. Now what is this limit? What is this limit? Yes. Yeah, because why this was 0? Because it's n tends to infinity. This goes to, this whole thing will become 0. But here it is independent of n, so the limit is going to be half, which is not equals to 0. Look at the test. It converges uniformly on the interval if and only if limit mn is 0. But because limit mn is not 0 and this is a necessary and sufficient condition, so it cannot converge uniformly. So therefore, I'll just fit here. Therefore, fn does not converge uniformly to f on AB. And what was AB? Any interval containing 0. And this completes the proof. Did you get it? Yeah. So I will just do these 2 questions on MN test. There are many questions in your book, in your exercise. You please solve that using MN test. If you are facing difficulty to find the maximum value, you please ask me. But the process is very simple. Okay. So this completes the uniform convergence thing. Next, in the next class, that is tomorrow, I'll start the consequences of uniform convergence. The consequence of uniform convergence. In the next class, I'll do that. That's all for today. If you have any problem, feel free to ask. I'll send the notes today itself. Thank you.